Amazon, YouTube, Spotify, what do these have in common with an academic search engine? Well, the answer is recommender systems. Today, I, Namrata, am here to talk about recommender systems, what they do, and how exactly they work. Now, I'm sure you've all seen a Netflix homepage similar to this one before. Have you ever wondered how exactly is it that Netflix knows which TV shows and movies to recommend? How does Amazon know which products to recommend after you're done buying one? Or how does Spotify know how to create that perfect playlist that's going to uplift your mood? Well, recommender systems are behind all of this. They are a class of machine learning algorithms that can predict whether a user is going to like a product or not, and accordingly forms recommendations which are unique to that user. This is why no two Netflix homepages are the same. It's like a fingerprint, it's unique only to you. According to Carlos A. and others, in a paper published in the ACM journal, 80% of the stream time on Netflix comes from this recommendation page, and only 20% comes from actually searched up movie keywords. This means that these algorithms are indispensable for this industry. As a computer science student, I was intrigued by these algorithms and decided to do more research on it. I'm here to share my knowledge about it with you all by talking about the phases of the recommendation process, the categories of recommender systems, and the applications of these systems. To start off with the phases of recommendation process, in a paper published in the Egyptian Informatics Journal, Efo Isinkaye and others outlined a three-phase recommendation process. The first one is the information collection stage, where data about the user, such as their likes, dislikes, the ratings, reviews, and how much time they spend on a particular web page, the views, counts they give, these are collected to create a user profile. In the second stage, which is the learning phase, the model is trained to extract more meaningful information from all of this data to create a profile about user likes, interests, the kind of content they like to watch, the genres they prefer. And in the third stage, which is the recommendation phase, the model actually predicts with different mathematical indicators on whether a piece of content is going to be enjoyed by this user or not. Now, based on the feedback on these recommendations, the information collection stage is looped to again by taking all of that data once more, and the cycle keeps going on. So this was a brief outline of how a recommendation process is carried out. Let's move on to the three main categories of a recommender system. Now, according to a paper published in 2019 by S. Zhang and others, there are three main categories of recommender systems. The first one is the collaborative filtering technique. This provides recommendations based on the ratings of other users and how those users interact with other pieces of content as compared to how you interact with it. In a paper published in 2018, Fatima A. and others said that these collaborative techniques work on basis of user item matrices, which try to find out relationships between how users interact with data and how similar two users are to each other. So this goes with the logic that if two users have always liked the same kind of content, if user 1 likes another new piece of content, it's likely that user 2 is going to like it as well, because they've always agreed in the past that they like the same kind of stuff. So the algorithm will then predict this new piece of data to other users similar to the first one as well. The strategy that is commonplace today is on Amazon.com, where it suggests the other products that customers have viewed based off of what you just viewed, because it's looking at what other consumers are doing and the things they are viewing to recommend things to you as well. The second type of recommender systems is the content-based recommendation, which works only on the attributes of the product, such as the type, color, if you're talking about movies, the director, the actors, the year it was released in, the genre, rather than how users and other users are interacting with this piece of content. Now, here's an example of a user using an academic search engine. If they like a particular piece of research article and there is another similar research article to that one, the second one is likely to be recommended to the user because the attributes between the two are very similar. Now, this strategy is seen mostly on video websites such as Netflix, where the because you watched section is highlighted to tell you that the movie that you just watched is similar to these other ones, and so you can check them out. Now, the third type of recommender system is the hybrid recommendation technique, and this basically combines the previous ones. So as you can see in the diagram, the recommendations provided by the collaborative filtering and content-based techniques are combined to give a hybrid recommended technique. And the hybrid recommender uses both user preferences, user data, how other users interact with it, as well as the attributes of the particular product to give a more curated product and recommendation for the user. So this is a better technique than the ones described before because it uses the advantages of these techniques but doesn't actually include the drawbacks of them. So I just outlined the three main recommender systems, which were collaborative filtering, content-based, and hybrid recommendation techniques. Now let's move on to the applications of these recommender systems. According to a paper by Ji Lun and others, published in the journal Decision Support Systems, there are several applications of recommender systems such as e-commerce, e-business, e-government, e-tourism, e-resource service provider, etc. And they also found out that the last category, which is e-resource service provider, is the one which uses these recommender systems most heavily. These are the ones that include the giants such as Netflix, Amazon Prime, Hulu, Spotify, YouTube, which curate video, music, and movie content for users. With further improvements in the future, we can actually see even more complex data being used to recommend things to viewers. And now that we know the basics of recommendation systems, we can work on these to improve the algorithms and come up with even more curated content. So the next time Spotify suggests a perfect playlist for you and you wonder, how does Spotify know exactly what kind of music I like? Don't be surprised. As is the case with most of the things in this day and age, it's just a bunch of algorithms doing their job. Thank you.